Hello, Unity developers. Today, we're going to encrypt the data in our game so that cheaters cannot easily see or change it by hacking into our game's memory. I have created the AES script. It provides two methods for us to encrypt and decrypt a byte array with an encryption key. I'm going to use the room ID as the encryption key so that our key always changes and not hard-coded, and only the players in the same room can understand the encrypted game data. We are going to use the AES 128 algorithm. It can take a key of 128 bits, so I'm going to add a method in the protected data class to calculate a key from the room ID. I'm going to take the first 16 characters of the room ID and encode them to 16 bytes, which is exactly 128 bits. And I will calculate the key in the constructor of protected data, so we always have an encryption key to use. We are going to protect the game data by storing it encrypted at rest, and only decrypt it and make it available when we need to access it. First, I will create a byte array to store the game data. I will call it save data. After that, I will implement the encrypt and decrypt method. In the encrypt method, I'm going to copy the code in the ToArray method to create a byte array containing all the game data. Then, I will use the AES script to encrypt the data with our encryption key, and I will clear the game data so that they cannot be seen in the memory. In the decrypt method, I will decrypt the save data and use the code in the apply byte array method to assign the values back to the game data. Next, I will update the ToArray method to return the save data and store the new byte array in the apply byte array method. Now we are ready to use the methods to protect the game data. For example, in the getGameState method, I will decrypt the save data first so that all the game data is available to use, and I will encrypt the game data after reading the game state so that all the game data is cleared in the memory. Okay, I have added the code to protect the game data. We need to be careful when using the returned value of the methods in the protected data class because the game data is cleared after use. So we have to use the returned values as if they are value types. For example, we need to call the setPoolOfCards method after updating the pool of cards returned value. At last, I will update the constructor of the game data manager to accept a room ID. I will use a default value that will be used offline. And in the multiplayer game script, I will create the game data manager with the room ID. And let's build the game. As you can see, all the game data is empty because they are stored in the save data byte array, and that will make it difficult to hack the data of our game. I want to mention that in this video, we are only protecting the game from memory hacks at runtime. There are other hacking methods that can make your game vulnerable. For example, your game can be modified and recompiled with injected code. It's almost impossible to protect the game 100%. If you really want to add real protection, you have to keep your game logic on a server, but that has its own issues. Renting a game server can be costly, and you need to maintain that server and scale it if needed. And that's it for today's video. Thanks for watching, and talk to you later.